there. We look for that area. All right, we got 1, 3, 8, 4, 2. A bit, and then in order to find this the length here, you have to manipulate a bit on the dimension. 250 plus 10 minus 90 is not mistaken. You got the value there, then you get the value. Right, this will be the maximum one at this one, and finally 500 just in case I just put it there, and so on. Okay, why we choose this one as possible maximum is because this even though the moment is not maximum, because of the shoulder, the stress will be higher. Apart from that, compared to here, even though this is 1005, this value the diameter going to be smaller here. That means the stress must be larger at this point. Okay, that will be what we have here going to be. Remember, basically we're going to have. Okay, I put them here. Going to be, we have, remember torsion that we have before this, the torsion 340 exponent 3 Newton millimeter, and we have a moment equal to what value? 1342.2, 1384, 1384.2 exponent 3. We call it kilonewton millimeter. Convert to Newton millimeter, there will be that value. Okay. Right now is determine the safety factor based on whether it's finite and finite life. Remember, if you recall this one, okay, I just will show you. At the end of the day, we have 3 equations, right? Okay, we have 3 equations here. Two equations. Sorry, we have one equation here, which is again fatigue life. The other equation will be again yielding. That means, okay, this one should be like, if this one should be larger than 1, that means you should check whether it's going to be infinite or finite life. Okay, if this value, the second value here, we call Goodman. Remember the Goodman diagram, the safety factor. If the safety factor is larger than 1, that means larger or equal to 1 going to be infinite life, and the value will be there. All right. What we should do is we have to find remember the 3 important part in the what I call it, finding the KF, SN, and determine whether it's going to be mean or alternative. Okay, right. That's the first step now. Okay, we just proceed with, okay, determine whether, okay, I have to move, right? Okay, whether this is going to be alternating, sigma mean, okay, shear alternating, shear mean. Okay, we take one by one. Let's say we take the moment first. Moment. Right? Okay, anybody? Just answer in the chat. What if moment 1382, what are you going to produce? Remember, this is rotating beam. Beam is rotating, the shaft rotating, and the load is constant. All right? Moment, is it going to produce sigma alternating, sigma mean, or shear alternating, shear mean? Moment first. Okay, can somebody just write on the chat? Is it going to be sigma alternating, sigma mean, shear alternating, shear mean? Please, somebody? Sigma alternating. Okay, right. That means this will be equal to sigma alternating. Let's see, I have my equation now. Okay, KF. Is it right? 32 moment will be 1384. Sorry, 84.2 exponent 3 power of 3 divided by, move a bit because otherwise I cannot write. Right? Divided by pi times, the diameter will be 40 power of 3. That will be the diameter. Okay, I just bring it here. Okay, too long now. Right, that will be for the moment. That mean will be equal to, okay, mean will be equal to 0. There is no mean. Right, how about the torsion now? Okay, the torsion, is it going to be sigma alternating, sigma mean, shear alternating, shear mean? Torsion, constant torsion on a rotating beam. Okay, can somebody write the answers, possible answers? It's going to be alternating. It's going to be shear mean. Yeah, that's correct. Okay, that means it's going to be shear mean here. That means this will be, okay, here. I want to make more space there. Otherwise, we cannot write. Cannot be moved. Okay, right? I just write again this one. Sorry. Equal to 16 times 340. Is it right? 340 exponent 3. Okay, sorry, forgot the KF. I just put down here at the basic because there's not enough space. KF. They call KFS because it's going to be in shear. Normally we have notation of S there. All right, exponent 3 divided by pi times 40 power of. Right, that will be the, all right, then this one equal to 0. All right, this one equal to 0. All right, right now, can you, okay, what you should do now is find the KF. Remember your KF formula will be KF equal to 1 plus 1 plus KT minus 1 times Q. Okay, the Q, remember, there's one single graph, there's two value. All right, and the KT is based on the type of parts as well as type of fluid. Okay, can all of you look for the value of what is going to be the shear alternating and, okay, sigma alternating and shear mean after find the KFS. All right, roughly quite long. There's so many tables to have to look for. Okay, I give you roughly 50 minutes, 8:45. Is it okay for the second one? Just to look for alternating and mean. Okay, sigma alternating and shear mean 8:45. 15 minutes. Make sure you will get the apa? Try find the books. You have to. There's a number of figures have to look for as well as the properties of the material. All right, 8:45. Okay, right, let's compare. Okay, right. First of all, to find the, what I call it, the KT, all right, for this bending, all right, remember, I show you the book now, right, in chapter 4, there's so many tables, stress factor, stress contraction factor, stress contraction factor, equation, stress factor. Remember, there's so many figures that you have to identify which figure to look for. Okay, our case is going to be shoulder, we select, going to be this one for moment, the first one for moment, and the third figure for a torsion. All right. All right, let me show it here now. All right. Okay, based on we have R, and R is 1.5 millimeter. This is from the figure. D smaller d 40 millimeter, larger diameter 45. Therefore, the R over D is 0.375 and D over D 1.125. If you look for this one, okay, this is 1.5 here, this 0.4, roughly, I say that will be 0.375. Okay, it's a 3/4 of the 0.3 to 0.03 to 0.04. Sorry, it's not 0.5, 0.005 here. The 0.004, 0.03. That means 3/4 between the 003 to 0.04. Okay, and we draw a line. Then we have to look at the line 1.125. We have 1.5 between 1 and 1.5. That means the 1/3 and the fourth line. 1, 2, 3, 3 and the fourth one. This will be the line between the 3 and the fourth line. All right, then what you should do, we interpolate again. All right, 1.25 roughly, and we get roughly the value of 2.02. Okay, you may get different answers because of your visual interpretation may be different, but not too far away from these answers. All right. For example, let's say you won't get 1.5, you might get 2.0 or 2.03, that's fine. 2.01, that's fine. But not get 1.5 or 1.8. Okay, that's too low. Like that will be KT, so static stress factor. Remember the Q, okay? The Q we have to rely on the figures, because remember the SU here, right? Then we have to look back at the, let me check the question, 10, SI 109 X roll, they have to look at the table appendix, remember the figure appendix, okay? Appendix C, properties, then we have to look 10950, right? 109 X roll, all right. All right, appendix C, let's just start this, what do you have here? Okay, 104, okay, that's not here, this hot roll. Look further, they will be cast iron. It's not cast iron, it's a carbon steel cast iron. This is a nodular cast iron. Okay, maybe here 1095. Okay, that's 1095 X roll. Okay, I take this value, then I insert it here. Right. All right. Then we have, okay, we have tensile 965.3 and 140, a bit different. If you use this book, a bit different. In BA first, the value going to be the same, but the way the figures show, for example, let's say, and the letter book, the latest book, this is 4, right? The fifth will be black and white, right? Okay, we have sorry, we have here. Okay, 140, and remember in KSI, it's not in when you refer to this one, you are using KSI. 140. Okay, 140 is perfect. 140, okay, that's perfect. That means this figure, remember, there's two here, there's bending here, because bending, and as a loading, this will share. That means we have to look, the figure will be around here. Okay, 1.5, the radial solder, 140, then we bring it back to here, then we get the value Q roughly 0.086. You might get 0.85 or 0.87, but not too much away from this number. All right. Therefore, we get the fatigue stress factor will be 0.86, 2.02 from the value here, minus 1, you got 1.88. Meaning that basically the stress increased by 1.8. Imagine, even that value, if you look this one, the 80% increase, 88%. This is not even 88%. For sure, this will be the highest critical point. Point C will be the critical point. And that means we are on the right track. Alright, that's done. That's the first part. On the second part, we do on similar thing. We use the 0.375 and the same thing. We have R over D 1.125. This is the thing we get 1.82. That is, I call it, even though the book is KTS, just to make S stand for shear, and actually to tell that the S will be in be equal to the torsion. All right, then we done that. Okay, this is a bit different. All right, imagine you have the value. There's two figure here. Okay, this is torsion, right? That means we have to do the graph here, and that they have to be aware of. All right, 140. We have okay, R is 1.5. Okay, 1 4. Oh, I cannot see that. I have to move this one. Delete here. All right, 120 to 180. Roughly, I interpolate again the result. This 120. Right. This 120. 180. Okay, in between will be 150. That means we are 140, roughly a bit in between. Half, that we got 0.88. That will be QS. Then we get 1 point, okay, we set the question 1.72. Okay, then we got this value. All right, the shear alternating will be 32 moment. Okay, we insert the value, we got 414.2 megapascal. And the torsion, be careful, the is when mostly students will forget about torsion because you cannot see torsion, you only see shear and moment diagram. There is moment, but for torsion, you have to take note of the torsion. All right, will be 46.54. All right, any question on up to here? Any question? All right, okay. Okay, that is done. Remember, we have three things. Identify identify the mean or alternating. KF, we've done that. And now what the next one is a annual limit. All right. Okay, go for annual limit first. Okay, we go for annual limit. Remember the figures, because the best you refer to the books. Figure 8. Figure table 8. I think the best thing to refer is the book, and don't refer to the notes, because book will be with you during the test, because you have to refer the book. All right, 8, figure 8 dash 1. Remember, figure, table is it table or figure? Table 8 point dash. Okay, this one. Okay, refer to this one. All right, let me make larger, a bit larger. All right, I think it's quite when you have this table 8.1, okay, if the value is not given, okay, you can assume it's equal to 1. Okay, all right, equation will be this equation. Cn prime will be 0.5 of the SUT, CL, CG, HS, and except for CL, you look for the figure 8.3, and there will be machine, because the question asks you is going to be machine. Right. Okay. Refer to this one. Okay. Roughly, I think 5 minutes. That's fine. I think quite except for one figure I have to do for 5 minutes from here. Roughly 9 o'clock. Is it okay? SN. Okay. SN 9 o'clock. Endurance limit 9 a.m. Okay, right, eh? And the limit, eh? Okay, the same thing. We have Sn prime, Cl, Cg, Cs, Ct, Cr, eh? Okay, remember I told you before this, to ignore this one. Why? Because at the end of the day, we're going to find the equivalent, eh? That's why we just use bending, basically. That means always equal to 1, eh? Even though there's a torsion there, when we equivalent, we are using a bending, okay? Because that Cl equal to 1, all right? Is equal to bending. Cg will be 40 millimeter. That will be 10 to 40, that's 0.9 here, right? That will be Cg. Cs, we base on our 140 KSI. We bring this line up until machine, remember this machine, 0.7 to CR and CT is not given, we can assume going to be equal to 1. Okay, that means Sm prime will be CL, C load, CS 11, this will be Cn prime 0.5, 965.3312.8 megapascal. Okay, right now we done everything. That the three major thing, KF and what I call it, KF, CSN, and so on. Okay, any question on the annual limit? I think quite straightforward, eh? All right. Right now, we look at the note again. After that, what we should do? After that, we should combine it, eh? Is it right? This is we're going to do. We're going to combine the alternating and alternating mean and mean, eh? Because of only this is 0, this is 0, this is 0, basically our alternating equal to equivalent alternating. Our shear mean equal to our equivalent sigma equivalent mean. Right? We have that value, then we insert this into these two equations here. Right? Set the value of equivalent alternating equivalent mean into Langer and Goodman. All right, that is very straightforward, eh? Right. Okay, just change it. Okay, then we use this one. All right. Okay, because of the this equal to 0, this equal to 0, and this equal to 0. This is my not sure. Sorry. We will get, that means equivalent alternating will equal to our alternating that we calculate because there's no shear alternating. The sigma mean, this is mean, the sigma equivalent mean equal to the shear mean as well, that means 46.54 because there's no sigma mean. Okay, that we get that value. We insert to the equation here. All right. Then we insert to the Langer. Remember the Langer equation here is going to be, we invert that value, we got the safety factor. That means equivalent alternating plus equivalent mean divided SY. And look at the table SY here. We need SY because again yielding. SY will be 572.3. That means we got 572.3 divided by that value. All right. Then we got 1.2. That means what you conclude here, that we will not fail at the first cycle, meaning that the part will not fail due to the static. That means fatigue will play the role now. All right. Then we go for Goodman. After that, we can go for Goodman because Goodman will determine whether it's going to be infinite or finite life. Okay, we insert to equation, then we invert the value, we got 0.7, meaning that the shaft will have a finite life. That's what is the conclusion here. That means that will be, you have to state this one, you have to state the meaning of white value. Don't just mention, okay, sigma is safety factor Goodman is 0.7. It doesn't mean anything, but you have to state the shaft will be have infinite. That will be added another 2 marks. You must state the meaning of the safety factor there. Okay, right. As you can see, actually, the difficult part is not is fine. And this is okay. This is good because this is going to be quite easy. The equivalent arithmetic equivalent mean we insert three equation. That what we got. We're going to be according to procedure. That will be, I think, plug the value into the equation. The difficult part will be the above part, the free body diagram, determine whether it's going to be alternating mean, the alternating the mean, shear alternating shear mean. Then after that, calculate HM. That in the stress, the mean and the alternating stress will have the same KF. The F value will be the same for the both. For certain book, they consider static will be mean. There's no KF, but juvenile consider as different because it depends on the books. Certain books, strictly, for example, the mean will be no KF. However, the mean here will be the same equation as distortion and theory. Okay, that's the reason why you need when you use strictly book a juvenile, you have to follow juvenile. If you strictly use strictly. All right. Okay, any question on the example exercise 1? Okay, I give you to 9, 10. Okay, to go through the example, then you have question, we can discuss. 9, 10, we can go through first, go through the process from A till you got the answers. Okay, 9, 10. All right, any question? Everybody good? Everything good? Any question, please? All right, eh? Right, we can go for the second question now. I think this, okay, I make smaller now. Right, eh? All right, a schematic class testing machine shown in figure Q2, eh? Always Q2 because it's getting from the time. The steel shaft rotates at constant speed omega. That means it's the rotating. And the loading is applied, and that means have a P here. There's a value, it's apply value P here from, and this value P at here, and then we give a, because the clutch, you need to have a certain force to the clutch, that means value P. And the torque induced based on that P, there will be a torque in function of P. Is right? There will be a torque in function of P. Torque equal to torque in function of P. That means you must add the value of P to the equation 2.0 there. Then we get the value of where the D and D are defined figure and what I call it, this is coefficient of frictions in the class surface. The shaft is 1045 hot roll. All right, this is 1045 hot roll. Okay, this is for material. All right, the static and factor KT are filled. Okay, that's good. It gives you the static and the KT. You don't have to find in the tables. That's good. All right. Okay. The static will be for extra loading will be 3. Right. Okay, that will go as a loading in yellow one. Right. The other one will be for 148 will be for torsion. It will be for, let's say, the green one. This one as well for the, okay, sorry. That will be the, that means the torsion will be, the SL will be 3, the torsion will be the green one will be 1.8. That is KT, static constant factor. You don't have to look for anymore. Assume the load P is synchronized with the shaft rotation. Assume CG is combined loading to the pure bending. It mentioned to you that the CG for this one assumed to be a bending loading. All right. All right. Find the parameters values of XY, ultimate tensile strength, SUT, annual limit, and fatigue stress factor. All right, that will be the first one. Okay, basically you are preparing yourself for calculate the stresses. Okay, I think this one will be quite not that long. All right, let's say 5 minutes, 18, 9:20, SY, SUT, SN, remember SN, CL, CG, and so on. 9:20. We're going to discuss 9:20. Okay, right. I think this is I think what is the material again? The material will be I think 1045. I think the first table, right? The appendix. Hold on, eh? Okay, appendix C3, if not mistaken. Okay, my capital is okay, it's C3 here. Okay, that will be 1045 hot roll, eh? Okay. Very important as well. Sometime what happened to last semester, what they did that they give the material here. Even though I never cover this material, you should be able to, because this carbon steel as well. This is a water quench tempered steel, carbon steel. That means that will be there's two material here. That more students, I think maybe out of 30 students, maybe only one or two students can manage to find the material. And be careful, there's so many more other tables that you look for. Beware of the possible of having different type of carbon steel, possible carbon steel, because the apathetic polycarbon steel, maybe different type of what I call heat treatment or process. They have to aware. You have to look back again of the table they have in the appendix. Right, that will be the value. 1045. Right, that you get the value SY 414 statistic SI. After thermal stress is 638 92.5. Okay, this will be, if you refer to this one, the type figure 8.1. Right, I think I don't go in detail because the answer in detail will be already shown before. Load will be 1.0 because it's a bending, you mentioned in the question. That will be the size will be, all right, let me check. Diameter will be 20. That will be 0.9. Okay, surface, we look for the artificial KSI. It's going to be, I think it's machine. I did hear about machine there. Is it machine? All right, the schematic that will rotate constant speed, fluctuating, induce, coefficient inflation. It's machine, You have to look detail from the question, It's machine. That means you have to look for this, because the hot roll, there's hot roll as here, that will be machine. Based on the SUT, you get the value, That will be the machine L equal to 1, D20 equal to 0.9, self-factor 0.77, not given, CT and CR will be 1 equal to 1. Experimental in the limit 0.5 SUT. Insert all, plug all the values into the line, you get 2.21. Okay. For the stress transfer factor, I think I just skip everything. The Q, this will be as a loading. Remember there's two, the same thing here. There is two, For the as a loading, we will be using this one. Double check whether this value. For the torsion, we will use this value. Okay, then we use the KSI here. Be careful, the one graph has two and same thing. That will double check with mine. You should get roughly 0.83 for the as a loading. KT given to you is 3, KTS 1.8, you got 1.699 and 6.69 and 2.6. That will be the KT and the KTS as a loading. This as a loading, I just put it here. This will be as a loading. This will be the torque or torsion. Okay, all right, that will be quite straightforward for the first question. Any questions so far? I think by this time you get the idea how to find everything, right? Any question? Okay. Right, if you have questions, just write on the chat. I will answer from that. All right, now we go for the second question. If the coefficient is 0.4, this is 0.4 here, right? P will be from 0, P P is 18 kilonewton, and that means the load variation is synchronized. There's something mentioned here. P will be P max. I think this is going to be P max. I think we should look at the question here. I think this is the correct question here. All right. Okay, the load variation is P is synchronized to rotation. That means the P will be from 0 to 18 kilonewton. You should mention somewhere. I think we'll given this, and I think there's a statement there that is don't give you that value. The P should be here. Yeah. I think you should bear in mind. I think maybe if you correct the exam, because the statement is from 0 to 18 kilonewton. Okay, meaning that the P is 18 kilonewton. Determine the equivalent. You should have the value. Okay, shaft rotating. Okay, this one. Okay, sorry. Right, be careful, Okay. The shaft is fluctuating from 0 to P. That means the value of P from 0 to 18, from 0 to P. It should mention here. Be careful, because it's a bit tricky there. You have to look the detail in the question, from 0 to 18. That means from 0 to 80 kilonewton, meaning that the load here are going to be your load. The load will be here will be all right. They have one mean at in the middle, right? All right. There's P mean here. Let's see, P mean PM mean this one will be of P alternating, right? Right, that is PA, P alternating, and P mean. Okay, this causes as well to have top mean when T at P equal to mean, and we have top alternating when T P equal to alternating. A stand for alternating, Pascal dia write the full word here, that the best way. Alright, mean, and this one will be alternating. Alright, P alternating and P mean. That will mean there's two here, they have 1, 2 there. Right, we have P alternating at certain value. We have P mean. We have shear mean, top mean, and the P equal to, when we insert the equation into the equation, we got the mean and top alternating, PA. Alright, based on the alternating torque, mean P, and mean torque. Okay, you should identify whether we have a sigma alternating, sigma mean, sigma, what you call it, sigma alternating, shear alternating, and shear mean. Okay, we can start one by one first. Okay, I hope somebody will answer in the chat. Alright, alternating as a loading, what it will produce? You're going to produce sigma alternating, sigma mean, shear alternating, and shear mean. Please, somebody. Okay, one more, alternating as a loading. Please, somebody, or I'll call somebody. Nur Amirah. Nur Amirah.
Yes,
Alright.
saya.
Alternating exile loading will produce Sigma alternating, Sigma mean, or shear alternating or shear mean.
Sigma min.
Alternating exile loading akan menghasilkan will produce what? Alternating exile loading.
0.
Okay, let's check here. There's two value here. The load will be fluctuating from P from 0 to 18, right? Right, meaning that there has a P mean and P alternating. Is it right? All right. When there's two value here, all right, the alternating PA for sure will produce Sinar, please. Sinar binti Anwar.
Yes, saya.
Okay. Alternating exile loading will produce Sigma alternating, Sigma mean.
Sigma min.
Alternating exile loading. When I say alternating, it will produce, for sure it will produce alternating, right?
Yes.
That means they will for sure it will produce alternating. This will produce alternating. Is it right? Because let's say we have the value here, this will be P equal to 0. We take our alternating here. That means if at this point, that will be 0. That will be certain value. That will be 9 or whatever value. That means we produce alternating. This value alternating will produce you here alternating. The mean for sure will produce the, because it's the exile loading that produce a mean. Okay, mean of the equation here, the mean will be the, when you insert equation with mean, for sure you produce the shear mean. And this one will be, happen to be, oh sorry. Okay, this one will produce the shear, oh sorry, not shear again. All right, they will produce shear alternating. Right, because of alternating, for sure you produce alternating. Like, look, you're right. Remember, when you have to think this, you have to think, even though it's rotate, okay, when they have a P here, it always constant regardless, Okay, that means when there's a value P, when the P fluctuating, that means it will produce alternating load. When P equal to 0, there's no exile loading. When P equal to whatever value mean here, the stresses will be equal to the, and so on. Is it right? That means the alternating PA will be rim alternating. Mean will produce mean torsion when equate to equation equal to mean, because shear mean alternating will go to the exile load shear alternating. Alright. Any question? Okay. Okay, is it okay, this one? Because remember, the load is from 0 to 18. That means it's going to be fluctuating. My camera on, All right, fluctuating like this. That means this is 0, this is 18. That means if you calculate this one, all right, this is 0, that I just mentioned here. This is 0 here. I put text here. All right, this is 0. This will be 18 at the top here. Meaning that if mean going to be, we add together, right? It means this is going to be equal to add it together divided by, put there, here. Create a new one, not to worry. All right, we put here. This one, add it together. 18 plus 0, the minimum value, divided by 2. And remember the note here? This one, all right? It's going to be the same as mean. That means the mean will be add and 1 minus for the alternating. All right, the alternating will be 18 minus 0 divided by 2 equal to 9. Both, it just happened both at the same value. Right. That means, okay, when we put value 9 here, 9 alternating here, we got the top alternating and top mean. Okay, any question? I think it's quite, you have to be vigilant on this thing, eh? All right, in this thing, how you get the alternating mean, alternating sigma, alternating shear mean, and alternating sigma alternating and sigma mean, as well as shear alternating and shear mean. It's rely on the load. Even though this rotate, a bit different from the previous one. Okay. Right? Any question? Okay. Can you proceed? I give you roughly 30, 47. All right. KF is it given? KF will calculate, right? I think quite fast this one. All right. Make it 10 minutes. Make it 45. Right. 9:45. Calculate all this one. Remember, there's a value KF here. They have calculated KF before this, KF and so on. Okay, 9:45. To calculate all the sigma alternating, sigma mean, shear alternating, and shear mean. The KF for the alternating and mean for the sigma alternating and sigma mean will be the same value. Even for the torsion as well will be mean and alternating will be the same value. All right, and 9:45. Okay, right. The solution I have here a bit different. Okay, instead of having the PA and P mean, the method here, I want to show a different way to look at the problem. Okay, we calculate the minimum normal stress and the maximum normal stress, right? Then we got that value. Then the same thing, we should have KF value. There's going to be alternating, that will be mean. You should get the same answers if you are using the equation here. For example, let's say this value, okay, you should get the same answers. It won't be different. For example, if you're using the value straightforward from the previous one, it equal to KF as a loading, P alternating divided by the A. A will be based on the area of diameter of 20. All right, divided by A. You should get the same value. The PA alternating will be 9 because the 9 got the same value here. The mean will be equal to KF. The same KF, it doesn't matter it's alternating or mean because it's already going to be this will be mean divided by A. The same thing. You get the same. I just want to show that the possible way to look at the solution differently here. You can do the based on P equal to 0, you got a mean, P over maximum, you get the P max, and you're looking for the nominals, alternating, and nominal mean. After that, time the KF to get the sigma alternating and sigma mean. Okay, for the torsion, you insert the value of P mean equal to 0, P max equal to 9. Right? They get 21,600 Newton millimeter. Then you get shear mean will be equal to 0. Shear max will be 137 nominal. This nominal. Then we got alternating, nominal alternating, and we got the mean alternating. Should be the same as when you do this way. This should be the same when you do. This will be KFS 16, right? 16, you insert the value on top, and 9 is alternating, right? 9 P alternating, insert the value divided by pi times 20 power of 3. All right? The same should get this one, the same for this one, and the same thing should get the same value. Then KFS equal to 16. P will be when the P equal to mean, Pn divided by pi times 20, 20, yeah, 20, power of 3. You should get the same value. And that's two way to look the way to the solution. You can use you can calculate the minimum stresses, maximum stresses, and find the alternating and mean stresses from that. Or you can go straight looking for the what call it the what we did, we're looking for the force alternating and torque alternating. We produce alternating shear, and the torque mean with the torque mean will determine the same goes with the axial loading. That's two ways to look at it. You should get the same answers. Okay, equivalent stress. All right, you insert all the values here. You will get the value of 215.2 MPa. And equivalence for the mean, you get the value of 160. And then you get the values. First of all, check again the safety again yielding, right? Then you will get the NL into 1.1. That means it's okay. You should write a statement here. Okay, the shaft, you should write a statement. This should have a statement here. The shaft will have will not fail at the first cycle, or we call it yielding. Will not fail due to the yielding. They may not fail due to static. All right, and this one 0.7. You find out the shaft will have infinite life. That's it. That will be the solution. I think the question number 2 Okay, it is both question here. Okay, the first question here is very straightforward. I think you can it's going to be quite long. But this question is just rely on your understanding on the which one is alternating, which one is mean. If you fail identify that, that's it. I think this question 2 here actually is simpler compared to the first question. It's going to be, but really test your understanding here. You make mistake at that one, that's it. You make a you can answer the question. Right. Okay, that will be 22. For this one, that if you see that I'm the what I call it, the example I give, I proceed until solving the problem here until the end. Okay. However, in the question, it didn't mention here, in the question here, if equivalent alternative strike is this one and equivalent mean strike is this one, determine the satisfactor. What it means that, okay, we want you to calculate here or up to here only, okay, up to here only, right? However, if you make mistake on that, okay, you don't you will not be punished. That the main reason to have okay, this one, that's why up to equivalent alternative equivalent mean up to here, right? Up to here, that's it. However, I will proceed to understand to answer at the end. However, for in this case, you answer up to here, then because you, I think the question here don't want to punish you if you make mistake here, then you will get a correct answers here. That's the main reason here. And always, there's two always number. The last question will be understanding question. All right. The same goes to here. Answering question. Let's say the first one will be if the radius of the fillet is increased. That means when the radius of fillet increase, the stressor on one critical point increase or decrease. Reason why. You have to statement, okay, why? You don't have to calculate that, but you just have to give your adjustment. Okay, when the increase, that means the changes, when the radius increase, the changes of we reduce the changes of dimension, and it cause the KT to be decreased and cause the stressor at critical point will be decreased. Okay, that kind of thing. The same goes for this one. Explain main character of the above hidden plot. Okay, that will be on this one. Actually, this figure. Okay, it asks you to plot into the SN curve here. How do you plot this one? Okay, is it going to be here, here, or here? Okay, actually going to be roughly here. That's it. Plot that thing. That's it. You got the answer to test your in case of graphical method. Okay. Right. I think for number 3, okay, that's it. You can do the. I think the main problem here is just a free body diagram. Okay. I think you proceed with this one as your exercise for training, and this one for number 4. All right. If you can see, okay, in one place, there are always 2 possible answers. Let's say the maximum will be, let's say, at A. Okay, the possible maybe here or here. Then you have to go 2 possible thing at the end, because the KT here will be different from KT here because there's a noise. This is a fillet. Same if the maximum here, you have to bring forward 2 till the end. That will be your homework. Right. I think question 3 will be on your own. You just test this one, but the key question here is that the free body diagram. If you can see the type of question that will appear, I cannot tell you what type of question, okay, but it will be test you differently. Some question will test you on the procedure, like the first one is very basic, but procedure. Number 2, actually is simpler. If you know everything, it's going to be simpler to answer. This one is actually simpler. The question is a lot simpler compared to the first one. Is to test your understanding on sigma, identifying the sigma alternating and sigma mean. Actually, this student have a bit of problem on this one. And I think they make sure that you have read all the single line here. Load of variation from 0 to, we have to understand the question every single line. All right, the third question I think will test you on the free body diagram. All right, that will become question. Okay, question from 4 will test your understanding. There is 2 possibility of having to carry forward in your further analysis. All right. Okay. I think okay. No. Okay. Before we end, any question regarding of your? I think we end the fatigue today. Next week will be the third topic. All right. You should submit your question number 4 by this Sunday, if not mistaken. This Sunday, question 4. And next week will be gear force analysis. And the other week will go testing on the gear force analysis. I think we can finish the topic for test run before semester break or before Aidilfitri. Then we can finish that. Hopefully, then you can. And at the same time, remember there's a major project at the start from gear because the gear the first part maybe next week I will explain on the major project. All right, any question before we end the meeting? The today class? Any, okay, go ahead.
Doktor, saya tak scan attendance lagi.
Tak apa, that's okay. I will show after this. Apart from attendance, not really. Apart from attendance, question on the. Okay, no question. Okay, right. Okay, we end the class. Okay, make sure you do the homework assignment. You can discuss with your friend, not to worry. I don't mind discussion with your friend, but not copy. Maybe 3 of you sit together. Maybe 3 of you stay at the time. Maybe sit together, discuss the method. Make sure you understand the procedure. That is the most important thing. All right. As I mentioned before that, your free body RAM will be very important. Identifying the demand attending mean will be another thing. KF will be another thing. SN. After that is just a procedure. Insert the value into the equation. That's it. If you look that I show you the first 2 example. Okay, I don't know why people really afraid of fatigue and static analysis. Okay, tackle the right thing. You should know the books inside and out. I will advise you if you have the book hard copy, you don't have soft copy, print it out because it's very easy for you to print the test. Easy for you to unless you have tablet on. There's 2. There's one. You have tablet very easy to use ruler. It's very easy for you to and hard copy. All right. One more thing that you have to the appendix, and the appendix thing that you have so many tables. Try to understand before test. Okay, this what table C1, C2, C3, C4, C whatever till the end. Okay, what is going to be? Okay, at least you know the carbon steel table. At least there's all coins, water coins, whatever tempered and so on. You know which table to look for. Not just table C3 or C5. That's the common thing that in the previous question, but maybe that's other table. That for sure, that other thing you have to aware of. Okay, make sure you have books. All right, we end the meeting today. All right, I just share you attendance for those who haven't signed yet. Okay, thank you very much and Assalamualaikum and goodbye and stay safe.
Waalaikumsalam. Thank you, sir. Stay safe.